Welcome to today's class on functional analysis. Today we discuss whether the converse of a Riemann-Lebesgue lemma is true or false using bounded inverse theorem. You know, the Riemann-Lebesgue lemma states that if x belongs to L1 of minus pi pi, then its nth Fourier coefficient x cap of n tends to 0 as n tends to plus or minus infinity. The converse of this lemma is not true. That we can see from the following theorem. So theorem, there are scalars kn in K for n equal to 0, plus or minus 1, plus or minus 2, etc. such that Kn tends to 0 as n tends to plus or minus infinity. But there is no x in L1 of minus pi pi such that x cap of n equal to Kn for all n equal to 0, plus or minus 1, plus or minus 2, etc. So we prove this theorem. Proof: let x equal to L1 of minus pi pi with the norm given by 1 norm of x equal to integral minus pi to pi modulus of x dm, where x in x, and you let y equal to, set of all y of minus 1, y of 0, y of 1, etc., extending to both sides, such that y of n belongs to K and yn tends to 0 as n tends to plus or minus infinity, with the norm given by subnorm of y equal to supremum modulus of y of n such that n equal to 0, plus or minus 1, plus or minus 2, etc., where y belongs to y. So you consider these two spaces, x with the 1 norm and y with the subnorm. Then x and y are Banach spaces, because x is complete by 4.6 and y is complete in the same way as C0. So the case of C0 is already proved. Now we are going to define a function from x to y. Now for x in x, define f of x equal to x cap of minus 1, x cap of 0, x cap of 1, etc. extending to both sides, where x cap of n is the nth Fourier coefficient of x. The Riemann-Lebesgue lemma says that x cap of n tends to 0 as n tends to plus or minus infinity. That is, f of x belongs to y for every x in x. Thus, f maps x into y and f is linear. Also, if f of x is equal to 0, that is x cap of n equal to 0 for all n, then x equal to 0 almost everywhere on minus 5 pi by 4.9c. This is by 4.9c. Thus, f is injective. Further, f is continuous since for x in x and n equal to 0 plus or minus 1, 1 plus or minus 2, etc. we have x cap of n equal to 1 by 2 pi integral minus pi to pi x of t e raised to minus int Fourier coefficients dm of t. So this implies a 2 pi into x cap of n equal to integral minus pi to pi x of t e raised to minus int dm of t. So this implies 2 pi into modulus of x cap of n. This is equal to modulus of integral minus pi to pi x of t e raised to minus int into dm of t. So this is less than or equal to integral minus pi to pi modulus of x dm, and you know that this is 1 norm of x. That is, modulus of x cap of n is less than or equal to 1 norm of x divided by 2 pi. So that subnorm of f of x, this is equal to subnorm of modulus of x cap of n such that n equal to 0 plus or minus 1 plus or minus 2, etc. Since modulus of x cap of n less than or equal to 1 norm of x divided by 2 pi, so this is less than or equal to 1 norm of x divided by 2 pi. That is, subnorm of f of x less than or equal to 1 by 2 pi into 1 norm of x. So this implies f is continuous. So we have seen that f is continuous. Now we prove that f inverse is not continuous. So however, f inverse is not continuous. This can be seen as follows. So for n equal to 1, 2, etc. 1, 2, etc. You consider the mth Dirichlet kernel. Consider the mth Dirichlet kernel. Xm of t equal to sigma n equal to minus mtm e raised to int such that t belongs to minus pi pi. Then f of xm equal to etc 0 0 etc 1 1 etc 1 1 0 0 etc 0 etc. Let it be ym, say, where 1 occurs only in the minus mth to mth entries. Now you know that norm subnorm of ym equal to 1 for all m equal to 1, 2, etc. But one norm of f inverse of yn, f inverse of ym, this is equal to one norm of xm. This tends to infinity. This is proved in section 4 while defining Dirichlet kernel. So you may go through that session. Therefore, f inverse does not belongs to BL of xy. Therefore, by bounded inverse theorem, f cannot be surjective. That is, there is some y in y such that f of x not equal to y for any x in x. In other words, there is no x in L1 of minus pi pi such that x cap of n equal to y of n for all n equal to 0 plus or minus 1 plus or minus 2 etc. Although y of n tends to 0 and as n tends to plus or minus infinity. So letting kn equal to y of n, we get the result. So that's all for today. Have a nice day.